So now that you know what the file paths represent, here's the attack. Let's say we have this file system and it's sitting on some server, and what is supposed to happen is that the user is able to enter the file name that they want, and the system goes into the backend. It looks in the home/public folder. It concatenates whatever the user requests and sends them the corresponding file. So maybe this is some image sharing service, and all of the images that the user is supposed to access are in this public folder. So the user enters their favorite file name. The backend looks inside the public folder, so it builds a file path using /home/public for everybody, adds the user's chosen input, and serves the corresponding file back to the user. So here, we send this file back to the user, and they see that wonderful image. Now try to be malicious. What if we use one of those weird file paths from earlier? Could that allow the user to access files that they're not supposed to? Remember, the user is supposed to enter file names. We put them in here, and that's supposed to only let them access the public folder. But what if we're malicious? What if we use that ... to go up and find things that we're not supposed to find? Well, in that case, once again, the backend will start with /home/public, and it will substitute in whatever the user provided, which in this case is ... /private/passwords.txt. We substitute that into the file path, and we figure out what file this corresponds to. Start at home, go to public, go back up, go down to private, go to passwords.txt, and now it looks like this backend is going to send the passwords file to the user. That was not supposed to happen. The user was only supposed to get these public files, but by using that ... to their advantage, they were able to obtain the top secret passwords file. That's the intuition behind this attack. So we call this path traversal, and the idea is we are exploiting how file paths are parsed. And a very common trick is to use ... to go up directories and then go into other directories that you're not supposed to access. So that was an example that we saw earlier. And the vulnerability is pretty similar to a lot of things we've already seen. So if you think back to SQL injection, user input was accidentally treated as SQL code. Or XSS, user input was accidentally treated as JavaScript. Well, in this case, user input was accidentally treated as a file path. So it's got similar characteristics to SQL injection or XSS. The only difference is that the language is not SQL or JavaScript. It is instead Unix file paths. Now, if we wanted to defend against this, we would make sure that the user input is not treated as a file path. So we would do escaping. We would escape any dots or slashes that we see. And if we wanted to do defense, that's how we would stop the attack. But for today, because we're thinking about detection, we'll think less about stopping this attack and more about detecting that it's happening. So keep this in mind as a running example for all the intrusion detection things we will see today.